Okay, so here's number one. Without even reading this, I'm pretty confident that the first reason is always going to be given. And we can justify, we can double check this, right? That this information here is the same as what's given up there. Okay, so we're trying to get from this given info to this, what we're trying to prove. Okay, I honestly like to just start by looking at the second step and trying to figure out, well, how can we say this based on the given info? Either the given info that's written or the picture, or sometimes a combination of the two. Okay, so here this says that CM is congruent to DM. So here's CM, here's DM. So how can we say that those are congruent? It doesn't say that specifically in the given info, but what it does say is that AB um, and CD bisect each other. Okay, so that means CD is cut in half by AB, and that's how we can say that. So the definition of the word bisect allows us to say that we've got congruent segments. Bisect means it cuts it into two congruent parts. Okay, so now moving on to the next step. So how about BM and DM? So BM, use a different color. It's right there, and then DM is over there. Okay, so it said that those two segments bisect each other, but that doesn't mean all four of the segments are necessarily congruent. I do know that these two are congruent from bisect, but that doesn't help me right there. Maybe those are congruent the way they're marked, maybe they're not. Okay, so let's see if there's another way. I can't really tell from the picture. Let's see if we can do something with the written statements. So if you look at the last two statements, I've got something that's equal to or congruent to CM here and here. And they're two different things, right? BM is congruent to that, and segment DM is as well. And so those two segments must be congruent to each other since they're congruent to the same thing, and that's what we have here. So this would be the transitive property of congruency. So transitive, and here's property of congruency, just in short form. You could also use substitution because since these are congruent, that means you can sub them in for one another. So where the you could sub in where the CM is, you can sub in BM, and there you go. So substitution will also work. Okay, and it's the substitution. I usually don't put equality or congruency for substitution because sometimes you go from an equation into a congruent statement. Okay, so next step, AB is congruent to AM plus BM. So kind of looking back, I don't see anything about AB or these. There is that little piece on C about BM, but I don't think I can do something with substitution or transitive property. So let's go back to the picture. So this is saying that AB, segment AB, is congruent to the sum of AM and BM. So in other words, that piece of the segment plus this piece of the segment, you add them up and you get the whole segment. Okay, so we're adding two segments together that are adjacent to get a larger segment. That's called the segment addition postulate. Okay, let's move on, see what we got next. And so when I'm looking at this next step, when I notice right off the bat it's almost the same as the step above it. Okay, so that always catches my attention because what I think when I see that is, well, the only difference is what I just underlined. The BM has now turned into segment DM. So that makes me think, well, maybe I can substitute in for BM. So I'd want to look earlier in my proof and see if I've got these two things equivalent, and I do, right? They're congruent to each other in step C, so that means I can take this and substitute in DM in place of it. So this would be substitution. Okay, and this is an instance where transitive does not work because we're not, yeah, so when we're looking at the previous steps, it's not that we have two things equal to the same thing so they're equal to each other, or I should say congruent. That's not the case here. You can't make an argument for that. So, yeah, sometimes they both work, like on this step, but this one, only substitution is going to work there. And that's the end of that proof, okay? So moving on to number 2, let's see what we got. So, without doing much reading, I know this is going to be given, and I can verify that. Yep, that's my given info. At the end of the proof, I'm trying to prove that angle AED is 90 degrees. So that should be the very last statement down here, and it is. There it is. Okay, so the hard part's getting there, right? And then in this case, just figuring out what reason we have for each step. Okay, so let me go back up to this. So these two angles, the sum is 90 degrees. So let me see, make sure I know what angles I'm talking about. AEB is this angle. BEC is this angle. Okay, and so together those form a 90-degree angle. How do I know that? Well, if you look at the given info, it doesn't say that specifically, but it does say that they're complements of each other. And complementary angles, that means that they add up to 90 degrees. The sum is 90 degrees, right? So I'm going to say the definition of complement. Or if you said definition of complementary or complementary angles, those would all be fine, okay? All right, so let's move on. We've got those two add up to 90 degrees. Now we've got those same two angles now are, when you add them together, we're gonna get this different angle, okay? So those are the two orange angles that I have over there again. And this step is saying the sum of those two measures is equal to the measure of the bigger angle, okay? So I've got two adjacent angles, so two angles that are glued together like that, that form a larger angle. So we had a similar kind of thing in the last problem, but there we were adding segments together. Here we're adding angles together. This is the angle addition postulate. Okay. Next step. Now AEC, that orange angle I just showed, is 90 degrees. Okay. Now you can actually make an argument that because we already said that the two smaller angles add up to 90 degrees, so we could say angle addition postulate again to turn this into that. But the way I'm going to approach this is that I have let's see. Okay, so I have, if I look at the last two steps, those parts are identical, okay? So I have the sum of those two angles equals 90 degrees, and then I have the sum of those two angles is equal to the measure of angle AEC. So that means, hey, I've got two things that are equal to the same thing, so they're going to be equal to each other by the transitive property, or you could use substitution again, okay? So transitive property, this time it's a property of equality, because we're talking about the measures of the angles, and you could also use substitution. Okay. All right. Now, how are we getting this, the 180 degrees? So, let's see. So let's highlight those. I was looking back at the previous steps and it wasn't quite clicking to me how I could get that from those statements. So when I feel like it's not going anywhere for me over there, I always move back to the diagram or vice versa. So let's make sure we know what angles we're talking about in the picture. AED is this angle, okay? And then AEC is this angle. So they're the two ones I have highlighted blue there. And together those form a 180 degree angle. And I can see that together they form a straight line, okay? So when you've got two angles that are adjacent to each other that form a straight line, They're called a linear pair. They make if you fit them together like a jigsaw puzzle, they form a straight line. They're a linear pair. The linear pair postulate says that anytime you've got a linear pair, the sum is going to be 180 degrees. So the sum of this linear pair is 180 degrees. So this is the linear pair postulate. Okay. All right, next up. Oh, right off the bat, I'm noticing, hey, not much has changed from step E to step F, just that piece. So I'm thinking maybe I can do some substitution, and I can right there. Those two things are equal to each other. So I can sub in for AEC, I can sub in 90 degrees. So this is going to be substitution. And again, this is not transitive property. That doesn't work here. Okay. All right. Now the last step, just looking at the equation, I'm thinking, well, this tells me what the measure of AED is equal to. So I'm thinking, well, what if I wanted to solve part F for AED, get the AED by itself? I would subtract 90 degrees from both sides of the equation. And if I did that, then I'd end up with this, right? So this is the subtraction property of equality. That's when we're subtracting the same thing from both sides of an equation. Okay, and that's number 2. All right, let's look at number 3. Okay. First step, given, because that's the given info. There it is. Okay. Step 2, got two angles that are adding together to form this angle. So let's highlight those angles in the picture. That over there. Here's angle 1, here's angle 2, and together they form this larger angle, because that's CBD, right? So hey, I've got two angles that are glued together to form a larger angle, two adjacent angles. This is the angle addition postulate again. Okay, I'm going to abbreviate a little bit, why not? That's what I mean, angle addition postulate, okay? Because I didn't leave myself much space, that's the reason I'm doing that. Okay, and then, oh, that same thing from the last problem, I'm thinking, the first thing that caught my eye is these look similar, and those two are changed, and you might think, oh, that's substitution, you can just sub in for angle 1. But if you notice, the angles at the end are different. So just subbing out the 1 wouldn't give me this equation right here, okay? So let's take a closer look at what angles we're actually talking about. We're talking about angle 3 here and angle 2. And when we add those two together, we get angle EBA. So here's EBA. So this is actually just the angle addition postulate again. I'm talking about the orange angles here, okay? So we've got angle addition postulate again. And that can happen sometimes, that you use the same reason more than once in a proof, and even twice in a row. Or, you know, you could use it 5 times in a row. There's no maximum amount of times that you can use a theorem. Okay. Sometimes you'll see steps B and C put into the same step with a comma because they have the same reason. So that's another way you could this proof could have been done. Okay. All right, now looking from here to here, now these are exactly the same except for this one little piece, right? So now this is where substitution is going to work. Those two things are equal to each other, so you can substitute where angle 3 is, measure of angle 3, you can substitute in measure of angle 1. This is substitution. Transitive does not work there. It's not that two things are equal to the same thing, so they're equal to each other. We're just, when there's more than one term and you're just changing one of the terms, transitive's not going to work. Okay. All right, and on to the next step. This is the last step. There it is. Yeah. We've got. Okay, these two angles are equal to each other. So I'm going back and looking through my previous steps here, and I'm looking for those two the measures of those two angles. And I've got EBA in the last two steps. And I've got CBD, the only place I see that in my proof. So I'm looking, what is that equal to over there? It's equal to 1 plus 2. So I want to use the version down here that's 1 plus 2. And when you think about those two, now I do have the same thing that's equal to two different things. So those two different things must be equal to each other. So transitive will work here. Okay, and pretty much any time that transitive works, substitution is going to work as well. But that's vice versa. The opposite of that is not necessarily true. Sometimes substitution only works on its own. But yeah, I could substitute in, for the into this equation, I could substitute. Those two things are equal to each other, so I could substitute in measure of angle CBD right here, and then I've got that equation. Well, it's flipped, but I could have substituted in the other direction. Okay. All right, so that's the first page. Let's move on to number 4. Okay. All right, first reason is given, because that's the given info, right? Just rewritten there. All right, let's move on to the next step. It says measure of angle 1 plus the measure of angle 2 equals 90 degrees. Okay, those add up to 90 degrees. How do I know? It doesn't say that in the given info, but it does say they're complementary, which means the sum is 90 degrees. So this is going to be the definition of complementary. Okay, or definition of complement or complementary angles, something along those lines. All right, next step, those two angles are the measures of them are equal. Well, I know they add up to 90 degrees, but that doesn't necessarily mean that they'd be 45 and 45, right? It could be 80 degrees and 10 degrees for all I know. So let's go back and look at the other info. I don't have anything to go on there, but if we look back to the given info, it says that ray BD bisects the larger angle. So that means that it cuts it into two congruent angles. So this is going to be the definition of bisect. That's how I know those two angles are congruent and their measures are equal. Okay. All right, so then we've got this equation, and I'm always kind of looking at the last couple steps and noticing, oh, it's almost the same as step B, but it's got measure of angle 2 instead of the measure of angle 1 in that position. And since those are in step C, I've already set those equal to each other. That means I can substitute in right here measure of angle 2, and then I got this. So this would be substitution. We're just subbing in one of the terms, so that means transitive will not work. Okay. All right. Here's the step where I see a very common error, and that's totally understandable, but I'm going to try to describe it to you. So, hey, I've got one measure of angle 2 plus another measure of angle 2. So, hey, now I've got two measure of angle 2s if you add them up, okay? So a lot of people will say, well, we did some addition, so this must be the addition property of equality. But you got to remember the addition property of equality, I'm going to work in the margin over here. If we have x equals 5, let's say, well, then we can say x plus 3 will equal 5 plus 3. We can add the same thing to both sides of the equation. That's the addition property of equality. But that's not what's happening here. We didn't add anything to the right side of the equation. We're just working within the left side. So that this is not the addition property of equality. We're combining these like terms. So you can say combine like terms when you're just doing some arithmetic on one side. We're also just simplifying on the left side. We're taking that and simplifying it into 2 times the measure of angle 2. So simplify will work as well. And either of those is fine. Kind of depends on what book you're looking at, but for me, I'm fine with either of those. Okay. And then the last step, we are doing the same thing to both sides. We're dividing both sides by 2, right? 90 degrees divided by 2 would be 45 degrees. So this is the division property of equality. Okay. All right, on to number 5. Okay. Given, and I'll just double check. Yep, that's the given info. Okay. All right, AM is congruent to MB, and there's more to this, but I'm just going to look at that piece first. So AM is congruent to MB. Okay, how do we know? Well, it doesn't say they are. Only thing it talks about is midpoints, and one of the things it says is that the midpoint of this segment is M, point M. So if that's the midpoint, then hey, those pieces are congruent. So because the midpoint, the definition of midpoint says that it's going to cut something, it's going to cut a segment into 2 congruent segments. So this is definition of midpoint. Okay, and that is also going to work with the second part of that given info, which is just saying that the midpoint of this orange segment is that, right? So it's also going to give us those 2 congruent segments there. Okay. All right. So now let's look at the next piece. So I guess I need a different color here for my picture. So yeah, I don't have anything like that in the previous step. So I'm going to go over to the diagram and see what I can do. So MD, that's this piece, is equal to this segment plus this segment. Okay, got 2 adjacent segments, 2 segments that are joined together to add up to get a larger segment. Adding segments, this is the segment addition postulate. They have to be adjacent segments that are joined together. Okay, all right, moving on. Hey, those look pretty similar. So let me see. I'm guessing those 2 I've already established are congruent, or they're equal. This means the length of these segments, right? And we do have that. BD and MB are equal to each other. We've established that. So that means we can sub in here. And again, we're only substituting in one of the terms. So transitive is not going to work. That's the substitution property of equality. Okay, and then this is kind of like this step on the last one. We're taking the 2 MBs, adding them together to get 2 MB. And again, you might think addition property, but we're only working on one side. We're not adding anything to the left side. So this is going to be either combine like terms or simplify. Okay, on to number 6. 2 more to go. First reason is given, and let me make sure, yep, that's the given info. Okay, let's move on. Then it says AB is congruent to BC. All right, so looking in the picture, that here's AB, here's AC. All right, so how can we get that? Well, if you look at the given, we only have really one place to go, and that's this statement right there. And in that statement, we have 2 things that are congruent to the same thing, right? AB and BC are both congruent to the same thing. That means they're going to be congruent to each other. And that's the transitive property, the way I just described it. But you could also do this with substitution. Okay? Anytime you can use transitive, you can also use substitution. All right, and then this is a short proof. Here's the last step. It says B is the midpoint of AC. Well, let's look at the diagram. If you know what the picture of a midpoint looks like, B is the midpoint. I can see that from this diagram because I've already got these 2 segments marked as congruent. So that means B is going to be halfway between A and C. It's going to cut it into congruent segments like all midpoints do. So the definition of midpoint is going to allow me to say that that's a midpoint because I've already established that it cuts that segment into congruent segments. Okay, and on to number 7. Last but not least. Okay. First step is given. I do want to take a second and talk about this symbol. Maybe some of you haven't seen it before. That symbol means perpendicular. And perpendicular lines or line segments or arrays, things that are perpendicular are going to form right angles. They're going to be at a 90-degree angle from one another. Okay. All right. So given info, then it says ABC, angle ABC is a right angle. Okay, ABC is right here, is a right angle. How do we know? Well, it doesn't say in the given info, but it does say they're perpendicular, and perpendicular means they form a right angle. So this is the definition of perpendicular. Okay, I'm very low on space here, so I'm going to use DEF for definition, and I'm just going to use that symbol for upside down uppercase T for perpendicular. Okay, next we have ABC. The measure of ABC is 90 degrees. Well, we've already said ABC is a right angle, and a right angle is 90 degrees, right? So I know it's going to be 90 degrees because I know what right angle means. So the definition of right angle is going to allow me to make that statement. Okay. All right, next up. Measure of ABC is equal to the measure of angle 1 plus the measure of angle 2. Okay, I don't see measure of angle 1 mentioned anywhere up here. So I'm going to go to the picture. So angle 1 is this angle, angle 2 is this angle, and together those form angle ABC, which is the one I kind of already had marked there. So got two adjacent angles, two angles that are joined together to form a larger angle. They're being added together, the sums. So this is the angle addition postulate. Okay. And then step E, we've got those two angles add up to 90 degrees. Okay. So let's see what we can do here. If I look at my previous steps, the steps C and D, I've got two different things that are equal to the measure of 90 degrees. Got 90 is the measure of angle ABC. 90 degrees equals that, and the measure of angle 1 plus the measure of angle 2 equals that. So that means these two things are going to be equal to each other by the transitive property or by substitution. Okay, running out of space there, so I'll use that for substitution. Okay. All right, and then last step. Now what we're doing is replacing angle 2, the measure of angle 2, with the measure of angle 3. We can do that if you go way back to the first step right up there. Those two things, they told us in the given info, are equal to each other. So we can substitute in here. We can substitute in the measure of angle 3. Transitive does not work here because we're just substituting out one term out of multiple terms. Okay, and that is it. So hopefully that's helpful. All right, see you later.